There's a new virus in the database.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display.
Down one set, 26.
Hello and welcome. Our discussion today will be regarding the secure architecture for industrial Internet of Things and industrial control systems, and why should we make it a priority securing these critical infrastructures. In the early days of the Internet, more than 40 years ago, the Internet was much simpler. It was more of a person-to-person connecting, sharing research papers across university labs. There was no data classification whatsoever, and information security wasn't priority. The rise of the World Wide Web, the digital age of business and digital media changed everything to the point of no return. Moving from person to business, and now business to things. Starting the era of the Internet of Things, where if it has an IP, you can control it. Our focus here is on the Industrial IoT and not on the consumer IoT, such the smartwatch you're probably wearing. Combining physical and digital experiences and creating a new wave of industrial revolution in which we are experiencing its cybersecurity effects in our present day. Industrial Internet of Things, or Industrial Internet, has been transforming our economies and societies and will be having bigger impact on our lives. So we have to make sure it is secure and trusted for what's ahead. IIoT trustworthiness, as identified by NIST CPS, is a combination of security, privacy, safety, resilience, and reliability, as the services they provide are critical to the livelihood of millions across the country, as it's the backbone of the new smart cities, and there is much at stake. So let's jump into the safety and security of the operational technology domain. Securing industrial IoT deployment against cyber threats remains a major challenge. The consequences of an industrial IoT security breach are much more severe than compromises of a traditional IT deployment. The Internet Engineering Task Force defined IoT as a network that connects uniquely identifiable things to the Internet. The things may be sensing, actuating, with potential programmability, interchanging capabilities. Practically, IoTs are essentially an enabler to digitize and interconnect physical assets by embedding the communication protocol stack and logic to appliances, sensors, actuators, or any device or machinery to intelligently communicate data without any human intervention. A cyber-physical system, CPS, refers to any network-connected instrumentation that interact with the physical world, such as the thermostat in your server room. In an industrial context, a common example of a CPS is an industrial control system, or ICS. An ICS is a general term used to describe a wide variety of control systems and instrumentations that is used to control industrial processes. The large-scale ICS are usually deployed using supervisory control and data acquisition (SCADA) systems, or distributed control systems (DCS), and programmable logic controllers (PLCs). All systems receive data from remote sensors, compare these with desired set points, and derive command functions that are used to control and process through the final control element, such as control valves. Our prime focus here is to protect the data itself. Data privacy and identity protection are the top priorities. The visibility into the controls is important. For example, if a temperature sensor in a power generation plant is hacked remotely, it can incorrectly output very high temperature values, which would cause the control system to shut down the entire power plant. Or even reversing that, in such the sensor output is much lower than what it should be, the control action may result in much more dangerous consequences, which what Stuxnet worm exactly did achieve. ICS SCADA control components are made of the following: control servers, master terminal units, remote telemetry units, sensors, a human-machine interface, data historian, which is the centralized logging database servers. In IT environments, data confidentiality, integrity, and system availability are the main priorities, not necessary in any particular order. While in OT, availability takes first priority and always after people's safety. Safety ensuring in the event of an attack that the affected system does not cause injuries, harm, or damage to the environment or people. As well, resilience, ensuring the industrial control system maintains state awareness and an accepted level of operation normalcy in response to disturbance, including threats of an unexpected and malicious nature. In an OT domain, attack surface is literally spread, as there is not much traffic traversing north-south across the DMZ. OT cyber threats involve a completely different type of adversaries. Threat actors' motivation in the case of ICS is less towards financial gains and often involves nation-state actors, whose prime motivation is to inflict large-scale disruption in businesses and national security. In an industrial IoT context, threat impact both the information and physical domains. The privacy and integrity of machine data in both controls and payloads have the potential to be exploited. Unauthorized access and manipulation of IoT platforms, softwares, and firmware are also potential threats. The best practical approach is always to adopt a defense in-depth strategy for your security. Some common types of attacks are ransomware, network protocol attacks, cryptographic and key management attacks, spoofing, data corruption attacks, denial of service and service jamming. We used good example in the previous EV security episode. Physical security attacks, access control attacks, privilege escalation. OWASP IoT project has done a great job in listing the most common types of IoT service attacks. Threat modeling within industrial IoT contexts is specified in 6 steps. Identify assets to protect, and you can find that in many of the frameworks, cybersecurity frameworks, starting with identifying the assets that you need to protect. Create an IIoT system architecture, which includes subsystems, platforms, application, data flow, and so on. Decompose the IIoT architecture into the system and use this to create a security profile. Identify threats based on the attack surface and vectors. 2 common techniques are used, Stride and Dread, both developed and deployed by Microsoft. Document these threats and last rate these threats, which is very important. Stride is a module to identify and classify threats and stands for spoofing identity, tampering with data, repudiation, information disclosure, denial of service, elevation of privilege. Dread, on the other hand, is used after the threat have been identified and classified. It is also important to rank and prioritize them. So Dread is designed to rank these threats, damage, reproducibility, exploitability, affected users, discoverability. In the DREAD classification scheme, threats are quantified, compared, and prioritized based on their risk value. The best cybersecurity architecture design for a production plant is to keep the OT and IT networks separated from each other, both logically and physically, keeping the OT environment isolated and air-gapped from the internet. Threats are typically limited to intentional or unintentional human error, physical access attacks, and other malicious activities. IT-OT network interoperability is increasingly being used and becoming the norm to extend process productivity towards monitoring and maintenance. Of course, the cyber threats associated with these expanded integrated networks are increasingly concurrently. Boundary protection is one of the solutions for securing IT-OT, and as we always say, there is no silver bullets. Boundary protections refers to installing boundary protection devices to control the flow of information between security zones that have different security requirements or policies. These devices include items such as gateways, routers, firewalls, IDS systems. The most common first line of defense between internet work segments is a firewall. Firewall devices consist of a combination of hardware and software used to control network traffic between untrusted or less secure networks and a protected network zone. A security zone is a network segment created to provide specific levels of security for specific networks assets based on the security vulnerability or criticality. A good security topology are designed to position and connect organizational assets such as servers, firewalls, routers, switches, and workstations within shielded network segments to protect them from unauthorized access or attacks. Firewalls used in OT environment are typically purpose-built to specifically monitor OT traffic and allow or reject traffic entering the OT or one of its subnets. Many IT firewall suppliers provide OT specific capabilities within their products. ICS environments started integrating newer technologies into the IT-OT network topologies, including cloud and computing integrated with 5G and Wi-Fi technologies, producing new IT-OT security architectural designs, such as the three-part IIoT, aka triple T's, which includes Edge, Platform, Enterprise T's, layered in 5 different levels. 3 ICS architectural design modules used today are the ISA 95 Purdue module, the Industrial or the Industry 4.0, and the SANS ICS 410. As they say, the Industrial IoT is more of an evolution than a revolution. With that, I will end here. Thanks all always for listening and have a great day.
The Rising Cyber by Chad Sally B.